Let's solve problem 8.15 for Microelectronic Circuits 8th edition by Sedra and Smith. We want to find the voltages of all nodes and the currents through all branches in the circuit, given that VBE is equal to 0.7 and beta is infinite. Now, this looks like a lot of stuff to find, but let's pause for a minute and just take a look at what's going on in this circuit. So let's start by looking at Q1 and Q3. So Q1 and Q3 form a current mirror. We know this because the bases of Q1 and Q3 are shorted together, and there's a diode connection from Q1's collector to base. So Q1 will have the same current as Q3. It will also have the same current as Q4 because its base is also connected. Now Q4 has the same current, so I'm just going to label this I, because all of these I's are equal. This will be the same I going through R2. Now let's go down to Q5 and Q4. So Q5 is also receiving the same current I, and Q5 is mirroring its current with Q6 because, again, we have a diode connection at Q5 and their bases are together. So this current through R3 will also just be I. Now if we move over to the left at Q2, which is receiving the same current I, you can see that it too is mirroring that same current with Qs 9, 8, and 7 because all of their bases are shorted together. So this current going through Q7 will be I. This current going through Q8 will be I. And if you do nodal analysis, you see that Q8 has a current I, Q7 has a current I, so the current going through R4 would be 2I. And lastly, we see that Q10, again, it's receiving the same current from Q9, I. Q10 is also mirroring this current to Q11, meaning that the current through R5 is also I. So practically the entire circuit has the same current, making this hopefully a bit less overwhelming. So now we can just start solving for some voltages. Let's go back to where we started, Q1. So this would be the voltage at the base of Q1. And again, this would be the same voltage for Q3 base, the base of Q4. So the voltage at VB1 will be equal to the voltage that's the emitter of Q1 minus the voltage drop from base to emitter. So this is equal to 5 volts minus 0.7 volts, which is equal to 4.3 volts. And we can already just start going. I mean, we have this voltage here. This is the collector of 3. What's the voltage at the collector of 3? Well, we just need to solve for the current first, I guess, actually. So let's see. I know the voltage here is just equal to VB1 still. So if I can solve for the voltage at this node, then I could solve for I using nodal analysis. So the voltage here, let's see, this is the voltage at the base of Q2. And what's this equal to? Okay, so the voltage at the base of Q2, again, if we travel from the bottom of the circuit, that would be the voltage at the emitter. And since we're going from the bottom to the top, this time we're going to add the drop from base to emitter. So this is equal to negative 5 volts plus 0.7 volts, or negative 4.3 volts. So now I can solve for I can solve for I. So the current would be equal to VB1 minus VB2 divided by R1. So that's equal to 4.3 volts minus a negative 4.3 volts, so we'll just add it, plus 4.3 volts divided by R1, which is 20 kilo ohms. So I get that I is equal to 0.43 milliamps. And again, this is pretty much the current going through the entire circuit except for R4. So now I can solve for the voltage at the collector of Q3. This would be 0 starting from the bottom, looking up, 0 plus the voltage drop across that resistor, so 0 plus IR2. So that's 0.43 milliamps times 8 kiloohms. This is equal to 3.44 volts. And let's see what else we could solve for. Let's solve for the voltage. How about here? What is this voltage? So this is the voltage at the so this is the base of Q5 and 5 and 6. How can we solve for that? What is the voltage at the base of 5? Well, again, if we travel from the bottom of the circuit, that would just be 0 because it's grounded, plus the voltage from base to emitter. So the voltage at the base of Q5 and Q6 would be equal to 0.7 volts. And I know the current going through here, it's mirrored, it's I. So how could I find the voltage here? This is the voltage at the collector of Q6. So the voltage at the collector of Q6 would be equal to 5 volts minus IR3. So that's 5 minus 0.43 milliamps. R3 is equal to 3.6 kiloohms. So that is equal to, right over here, voltage at the collector of Q6 is equal to 3.45 volts. All right, let me clear up this work and we will keep going through the circuit. Alright, so let's keep moving along the circuit. Again, the current that we solved for is 0.43 milliamps. We've pretty much solved for everything on the right half, so let's move over to Q7. Specifically, let's look at R4. So again, we know the voltage here is negative 4.3 volts. Let's try to find the voltage here. So we already discussed that every transistor has the current I going through it. So through Q8, you have a current I. Through Q7, you have a current I. And that means that the current going through R4 is 2I. So if I were to solve for the voltage here, this would be the voltage at the collector of Q8 and 7. I'll do 8. So the voltage at the collector of 8. If we're going down this circuit, that would be 0 minus 2I R4. So the voltage at the collector of 8 is equal to negative 2 times the current, 0.43 milliamps, times R4, 5 kiloohms. And this is equal to negative 4.3 volts. And then let's keep moving along the circuit. So let's see. If we go to here, again, this current is still just I. What's the voltage here? So this is the base of Q10 and Q11. We can solve for this directly by just taking 10 volts and subtracting VBE. So that would be 10 minus 0.7 or 9.3 volts. All right, and then I think that just leaves, this voltage here. So this is the voltage at the collector of Q11. And again, Q11 is just receiving that same current as I. So if we travel from the ground, that would be equal to 0 plus IR5. IR5. So the voltage at the collector of Q11 is equal to I, which is 0.43 milliamps, times R5, 10 kiloohms. So the voltage at the collector of Q11 is equal to 4.3 volts. And that should be every single node voltage and current in this entire circuit. Thank you for watching our video. For any questions or comments, feel free to leave them in the comments section or to contact me by email. Thank you, and have a great day.